Okay, this is 8.5. It only has 2 questions. So, for the triangles below, use the tools to move the solid triangle exactly onto the dashed triangle. So you have a translate button, a rotate button, a dilate button, and then 2 reflection buttons. So, if you use the translate button, which one do you grab? Move the solid triangle onto the... Okay, I'm going to have to do this from my desk. So translate, we can slide it, and then if I need to, I can rotate, or I can dilate, change its size. I can reflect in either of those 2 directions. So for this one, I'm going to translate, and I'm going to rotate. Oh, I'm going to need to flip it. And then rotate. And then dilate. There we go. Okay. Then it asks, find the following ratios. So FG divided by JK. So JK is 10 and FG is 5. So 5 divided by 10 is going to be 1/2. Okay. Complete the congruent statements. Angle J is congruent to, so which one is J going to be congruent to? F, E, or G? It's going to be F. So the biggest angle is congruent to the biggest angle, and the smallest angle will be congruent to the smallest angle, and then the middle one to the middle one. Okay, and then when you select the similarity statement, JKL and FGE are similar. So J lines up with F. So J and F, it could be this one. Let's come up here. So K is between the 10 and the 16. So K and G are congruent. So G, and that would leave E. So JKL is similar to FGE. Oh, they are similar. Okay. Well, actually, we need to do that. 5 divided by 10 is 1/2. 7 divided by 14 is 1/2. And 8 divided by 16 is 1/2. And since all of these are 1/2, then yes, they are similar. Okay. Are these similar? So we do long divided by long, 9 divided by 6, and then middle divided by middle, 6 divided by 4, and 5 divided by 3. Are 9 over 6, 6 over 4, and 5 over 3 all the same length? No. So these are not similar. Okay. So here we have right angles that match. This is 55 and this is 35. If this angle is 55, how big would this angle be? 35. And if all 3 angles are congruent, then yes, they are similar. And then you need to, by the angle-angle postulate. Okay. So if they have 2 angles that match, or really 3 angles that match, then they are similar by the angle-angle property. Okay. Yeah, you need to type in, so JKL, and then you would need to type in the matching sides, or matching angles. Okay. What if all the ratios were the same? What if it was 10 over 5 and 6 over 3 and 4 over 2? Then you would say yes by the side, side, side. So if all three sides give the same ratio, then you choose side, side, side. Okay? And then the last option is side, angle, side. So if you have two angles that match, I better do this one up on the board. So side, side, side works like this. We have two triangles that kind of appear the same, and we have 10, 8, and 12, and then we, oh wait, we don't need that. 5, 6, and this is 30 degrees. Okay. 10 divided by 5 is 2. 12 divided by 6 is 2, and the angle is the same. But you have to be really careful here. It only works if you have side, angle, side, where the angle is between the two sides. So if I were to change this, and I had 10, 12, 5, 6, and 30, is that side, angle, side? No, that is angle, side, side, or you could say side, side, angle. So this only works if the angle is in the middle, if the angle is between the two sides, and the two sides are similar. So if I went like this, are those similar? We are looking at side, angle, side, but 10 divided by 5 is 2, and 8 divided by 5 is not 2. So there are three similarity theorems. One is all three sides give the same ratio. The other is all three angles are congruent. And the third one is side, angle, side, where the angle is between the two sides and then the two sides give the same ratio. 10 over 5, and then if this was a 4, then that would be similar by side, angle, side. All right, get to work.